I want battle! No, no battle for me. Only positive comments from positive people. No trolls. Thanks for your nice replies. I try to reply to all of you, as you can see. Thanks a lot. Thanks all. So this is an extended version of my video, and I show some more bullshit. If you are interested, I start the video with how space and rockets came to life. It's just a fantasy story. If you want to see the full video, then I suggest to type this in YouTube, and you will find the link. I'm going to play some small parts of it. Peace.
I'm Mike Wallace. Our title, The Race for Space, means the contest between the United States and the Soviet Union for propaganda and military advantage. Our program will show that contest, and you will see American films and also Soviet rocket films never before seen by anyone outside the intelligence services. But more important, our program will show you that the race for space has always involved a great ideal, a dream that existed long before the Cold War, one of man's oldest dreams, a trip to the stars. To understand the fascination of the stars, to understand why the dream of the exploration of space has so completely captured the mind of the modern world, you must let your imagination soar. Soar like a rocket. Imagine not only the white sands desert of New Mexico far below, but all the deserts of the world, like Africa's famed Sahara. Imagine all these deserts and all the other sandy wastelands of the world. And now realize that for every single grain of sand on Earth, there is a star in the sky. Think of it. For every single grain of sand, a star in the sky. In 1898, the 20th century science of space travel was founded by this Russian schoolteacher, Konstantin Eduardovich Tsiolkovsky. There have been many Russian claims of firsts in science, but it's been authenticated that 60 years ahead of his time, Tsiolkovsky stated that the development of rocketry would lead to space flights. And in 1903, he designed and built this model spaceship. He also coined a new word for the artificial Earth satellites whose creation he predicted. He called them Sputniks, the Russian word for fellow travelers. Today we are able to hear one of his granddaughters, Marie Samburova.
She fucking rocket scientist.
Grandfather had many visitors, scientists.
Let me guess who these scientists were back in the days. Nielski de Krasky and Kalski Sekansky.
Fascinating stories of how people would someday fly to different planets.
For it was an American, Dr. Robert Goddard of Worcester, Massachusetts, who turned modern rocketry from a theorist's dream into an engineering actuality. Dr. Goddard began his rocketry researches as early as 1913, and in scientific circles he soon won respect. But it cost money, which he paid out of his limited salary as a college professor.
No, the mental institution paid for that. That was part of his therapy. Rocket therapy.
he proposed using rockets to carry scientific instruments to the upper atmosphere and to the moon.
Let me guess. He wanted to use Weener from Braun's rockets.
Post-World War I Germany, there were a handful of idealists who'd heard of Tsiolkovsky and Dr. Goddard and who believed in the dream of travel to the stars. The leader of this group was a distinguished theorist, Dr. Hermann Ober. He, along with a few others, formed the German Society for Space Travel. One of the most enthusiastic members of this little group was this 18-year-old boy, destined to become one of the giants of the American space program. His name, Weener von Braun. Using some of Goddard's ideas and many of their own, the Germans experimented with the rocket in all sorts of ways. But after many failures, they were learning what Goddard had already shown, that the greatest future for the rocket was in space flight. Like Goddard and many other scientists, the German Space Club members were in financial trouble and were about to disband. At this desperate moment, Germany's most distinguished motion picture director, Fritz Lang, came to their rescue. He was about to make the world's first modern science fiction movie, Frau im Mond, or Woman in the Moon. Would the club members serve for money as the movie's technical advisors? The answer was yes. You are now looking at actual scenes from this German classic produced in 1928. To make the launching more dramatic, Lang hit on the idea of counting backwards until the actual moment for firing. The German rocket pioneers then spread the dramatic notion of the countdown throughout the world.
So that countdown originates from a thing that a movie director made up.
Most important of all, in addition to money, the Space Travel Club was also paid with all the props they could walk off with. These props were then used as the actual components in the Space Travel Society's rockets.
So, those guys getting paid with the movie props from cardboard.
They proposed using rockets to carry scientific instruments to the upper atmosphere and to the moon. But it wasn't long before the movie proceeds too had all gone up in smoke. And desperately, the club began to look around for a new source of funds.
Let me guess. You helped the Germans. You went from cardboard movie props with engines to V2 rockets.
Minus 10 seconds.
In the middle of the 20th century, for the first time in history, man reached beyond his planet and began to probe the mysteries of space.
I love space science. Especially those videos from the National Academy of Sciences Those guys know what they put out.
This is one of the tools with which man is creating a new age.
The Vanguard rocket that puts satellites in space. It's an awesome rocket.
Offers a good example of basic technique. 72 feet long, as tall as a 7-story building,
That's a 777.
the 3-stage rocket takes off, bearing the satellite. Its path has been set before launching. Guidance equipment in the 2nd stage keeps it on course. About 2 minutes after launching, nearly 40 miles above the Earth, the 1st stage burns out.
So the first stage after 2 minutes.
Nearly 40 miles above the Earth, the 1st stage burns out.
40 miles above the Earth. So in about 2 minutes. 40 miles in 2 minutes. That's 1200 mile per hour. That's not fast.
Falling into the sea as the 2nd stage fires. The rocket continues along a curved path. It is now climbing through such thin air that shielding from air friction is unnecessary. The nose cone is jettisoned. Nearly 5 minutes after launch, 140 miles out, the 2nd stage burns out.
5 minutes and 140 miles out. 140 miles. 5 minutes. That's 1680 miles an hour. That's not so fast.
The rocket coasts on to a height of about 300 miles. At this point, it is traveling parallel to the Earth's surface. However, the vehicle is traveling only 9,000 miles an hour.
And now it suddenly flies 9,000 miles an hour.
Nearly 5 minutes after launch, 140 miles out, the 2nd stage burns out. The rocket coasts on to a height of about 300 miles. 5 minutes after launch, 140 miles out, the 2nd stage burns out.
So the 2nd stage burns out on 140 miles.
The rocket coasts on to a height of about 300 miles.
And then automatically it propels to 300 miles altitude. That's kind of strange without propulsion.
At this point, it is traveling parallel to the Earth's surface. However, the vehicle is traveling only 9,000 miles an hour, not yet fast enough to overcome the pull of gravity.
Yeah, suddenly it fly 9,000 miles an hour without propulsion.
And stay in orbit. Inside the 2nd stage, the 3rd stage, containing the satellite, now begins to play its part. Small rockets start it spinning on a turntable. When the spinning reaches 150 revolutions per minute, the 2nd stage is separated, its job completed.
How does it get separated? I don't see the engine burning.
Stabilized by its spin,
Oh, now we see the engine got ignited. That's kind of magic.
the mysteries of space. The 3rd stage fires and gathers speed. Then it too burns out and ejects the satellite into orbit at 18,000 miles.
So this tiny engine can add another 9,000 mile per hour speed extra to this 9,000 mile an hour. That's some pretty nice science.
The mysteries of space.
So let us hear it again.
2 minutes after launching, nearly 40 miles above the Earth, the first stage burns out,
So this is 1200 mile an hour.
falling into the sea as the second stage fires. The rocket continues along a curved path. It is now climbing through such thin air that shielding from air friction is unnecessary. The nose cone is jettisoned. Nearly 5 minutes after launch, 140 miles out,
So it goes from 40 miles with 1200 mile an hour speed to an altitude of 140 miles in 5 minutes with 1680 miles an hour. So in 3 minutes it accelerates only with 480 miles an hour.
the second stage burns out. The rocket coasts on to a height of about 300 miles.
So without propulsion it goes from 140 miles to 300 miles.
At this point, it is traveling parallel to the Earth's surface. However, the vehicle is traveling only 9,000 miles an
And now suddenly 9,000 miles an hour. That sounds like magic.
The mysteries of space, not yet fast enough to overcome the pull of gravity and stay in orbit. Inside the second stage, the third stage containing the satellite now begins to play its part.
So this engine is not burning from the big last stage, if I'm correct.
Where the
Yes, it's not burning.
vehicle is traveling only 9,000 miles an
And then it accelerates from 9,000 miles an hour to 18,000 miles an hour.
The nose cone is jettisoned. Nearly 5 minutes after launch, 140 miles out, the second stage burns out.
So 140 miles out, the second stage burns out.
The rocket coasts on to a height of about 300 miles.
So and then without propulsion it goes from 140 miles to 300 miles and still have no propulsion.
At this point, it is traveling parallel to the Earth's surface. However, the vehicle is traveling only 9,000 miles an
And now it suddenly goes 9,000 miles an hour. That sounds like magic.
The mysteries of space, not yet fast enough to overcome the pull of gravity and stay in orbit. Inside the second stage, the third stage containing the satellite now begins to play its part. Small rockets start it spinning on a turntable. When the spinning reaches 150 revolutions per minute, the second stage is separated, its job completed.
So then it gets separated. I don't see fire coming out of this rocket.
Stabilized by its spin,
And now this rockets get ignited.
the third stage fires and gathers speed. Then it too burns out and ejects the satellite into orbit at 18,000 miles.
And then we just add another 9,000 mile an hour. Piece of trash.
Looking for a satellite is almost like dragging the Pacific for a golf ball. Some of them can be seen by the naked eye.
Yeah, you can just see them with his binoculars on hundreds of miles distance through all that atmosphere. Yeah.
Or with binoculars, but only around twilight.
So you're telling us you can see this on 140 miles distance in space. People can hardly see that thing called ISS. But now you can see this small thing with your binoculars. Get the fuck out of here. Look at this nose cone. It's not even attached to the rocket. Look, it just drops off. This is just a mock-up.
Other tests ensure that the rocket's nose...
So this is the rocket nose with an explosive device.
So that the satellite can be separated from the rocket system.
So how does it get attached to this bottom ring? I don't see it. With your tiny satellite, which can be seen on hundreds of miles distance. Yeah, I don't see pins here. So it can slide off. This is just a fantasy mock-up. I don't see him on this side, and I don't see him on this side. So what is holding the nose cone? Nothing.
Tests ensure that the rocket's nose
So we can see the explosion here on this side. This is just trash. So I think this is the device that made the explosive. And how comes it opened so evenly?
so that the satellite can be separated from the rocket system. Other tests ensure that the rocket's nose will open up and fall away, so that the satellite can be separated from the rocket system. Finally, what about the information obtained through satellite?
Yeah, what about that information? Let me know.
The first finding, interpreted from tracking data of Vanguard 1, provided new facts about the shape of the Earth. Facts that could be
Yeah, looks pretty level.
obtained only from a satellite. Minute differences in the repeated measurements of Vanguard 1's orbit led.
So this is a retrograde orbit against the rotation of the Earth. Space agency like NASA launch rockets near the equator to gain more speed from the rotation of the atmosphere. It helps the rocket, and that's a west to east motion, of course. So if this atmosphere is rotating in a west-east direction to help the rocket, then this rocket have to go against the spin of the atmosphere.
Nearly 5 minutes after launch, 140 miles out,
So with this speed, this 1680 miles an hour, we have to take off a 1000 mile an hour spinning atmosphere, because this goes against the spin of the atmosphere, of course. According to science, the atmosphere not rotating in two directions. This sounds like magic.
the mysteries of space.
You cannot have it both ways, of course. Yeah, look at this actor. Why are you so happy? This is just a movie set, actor. Yeah. What we must think of you guys here. You guys provided all the information for this so-called documentary. It come not drop from space.
The mysteries of space.
About techniques and materials for re-entry to protect the astronauts and their spacecraft from this extreme heat, we talked first to Mr. William Brooks, head of the Entry Structures Branch here at Langley.
When the spacecraft re-enters the Earth's atmosphere, by a process of compression and friction, a hot layer of air is formed over the frontal part of the vehicle. The temperature of this air may be as high as 20,000 degrees for the Apollo vehicle.
20,000 degrees. That is the highest I ever hear. 20,000, 15,000, 11,000, 10,000, 7,500, 5,000, 4,000, 2,500. So which one is it, Mr. Kennedy?
re-entering the atmosphere at speeds of over 25,000 miles per hour, causing heat about half that on the temperature of the sun.
The dish-shaped heat shield designed to withstand re-entry heat.
For nearly 1,000 seconds, as the command module smashes into the atmosphere, it will be exposed to heat which can rise to over 5,000 degrees Fahrenheit.
They shield their eyes as they see a replica of their space capsule being subjected to 11,000 degrees of heat, such as it will encounter when it flashes back into the Earth's atmosphere.
3,000 degree heat.
2,500 degrees.
4,000 degrees Fahrenheit.
Still heat up to 7,000 degrees Fahrenheit.
2,400 degrees Fahrenheit.
The surface temperature of the ship reaches 10,000 degrees.
20,000 degrees for the Apollo vehicle.
Consists of several layers of laminated fiberglass resin.
And then return it safely to Earth.
Increased substantially following flares on the sun. This finding led to a new theory. Charged particles streaming toward Earth after solar flares increase atmospheric density enough to affect a satellite's orbit. Satellite tracking data provide information about another factor nearer Earth, the atmospheric density which ultimately destroys them.
So the atmospheric density destroys the satellites. That means they orbit in our atmosphere.
By studying the decline of a satellite's orbit as air drag slows it up.
Since when we have air drag on altitudes where satellites fly?
200 to 400 miles. Scientists compute atmospheric density at many levels. Analysis of such data has established that at heights of 200 to 400 miles, air density is at least 10 times greater than was estimated in the days before satellites.
So now we have air on a couple of hundred miles altitude.
200 to 400 miles.
Declining satellites altitude. What happened to gravity? Oh well, maybe they didn't invent it yet. Science today say it's gravity is the cause of declining satellites. Gravity is the solution for everything. We even have 90% of gravity on the ISS, its altitude. If you weigh 100 pounds on Earth, you will weigh 90 pounds in the ISS. But you need to go 17,500 miles an hour in Earth's atmosphere, in the air, because there is air drag, according to our early science, because they research all the data.
Analysis of such data has established that at heights of 200 to 400 miles, air density is at least 10 times greater than was estimated in the days before satellites.
A giant rocket, more than 300 feet tall, made of new metal alloys, some of which have not yet been invented, capable of standing heat and stresses, fitted together with a precision better than the finest watch. The length of this football field.
20,000 degrees for the Apollo vehicle.
And then return it safely to Earth.
How can those guys can get safely to Earth with 8,000 meters a second? The Earth is rotating the Sun with 28,000 meters a second. It never catches up with the Earth. And when this tiny module comes from the other direction, it would smack into the Earth's atmosphere with 36,000 meters a second instead of 8,000 meters a second. This really sounds like magic.
The mysteries of space.
Houston, we've had a problem. This is Houston. Say again, please. Say again, please. This is Houston. Say again, please.
300 miles out, beyond the dragging effect of the lower atmosphere, it continues to move at its original orbital velocity. Satellite orbits, like those of the planets, are elliptical, with a far point, the apogee, and a near point, the perigee.
I always wonder how those satellites can catch up with the Earth. Maybe I don't understand orbital mechanics, or that we have air on 200 to 400 miles. And maybe I also don't understand this Vanguard rocket can go to space with 680 mile an hour. Nice video, National Academy of Sciences. So this must be approved by more than one person, of course. Even Weener von Braun was member of that academy in Braun, Washington. That Vanguard rocket is a direct ascendant from the V2 rocket, Science in Space. One of a series of reports on man's studies. What did you study? Oh yeah, the satellite data. Yeah, smart man. Study planet Earth. I love this video.
In 1958, the Van Allen team, their experiments riding on the first satellite, Explorer 1, discovered great seas of intense radiation swirling about our fragile spacecraft, Earth. A vibrant, turbulent teardrop shaped by the million-mile-per-hour solar wind.
Million!
Million-mile-per-hour solar wind, tormented by severe turbulence on its shock front, and buffeted into a streaming tail stretching millions of miles away from us, away from the sun. This enormous sea of charged particles and magnetic fields is affected by every mood of the sun.
Dr. Van Allen's tiny satellite discovered some dangerous stuff. That solar wind of 1,000,000 miles an hour can even leave a sunburn on the moon. Because the moon don't have as strong as magnetic field as the Earth. Yeah, the moon has a weaker magnetic field. And that's why some areas of the moon are exposed to the sun's damaging radiation. According to NASA, of course. Unlike Earth, the moon doesn't have a global magnetic field, but magnetized rocks. And they are creating small localized magnetic fields. That's interesting. The magnetic field of the moon is very weak. Yeah, the major difference is the moon don't have a dipolar magnetic field. Yeah, it's difficult to compare its magnetic field compared to the Earth. So on the moon it's about 5 microtesla compared to Earth's 50. So that was not so difficult to compare. It's all theory and hypothesis. They even analyze the magnetic rocks brought back from the moon by the Apollo astronauts. You mean this rock? So this rock was given to my country in 1969 from the Apollo 11 astronauts. Petrified wood. So there must be trees on the moon in the past. You piece of shit. That moon science is very interesting. The crust. So they must have drilled in the crust. Let's see how deep they drill.
Okay, second one going in, Tony Mark. Don't strain yourself there, Charlie. Houston, we've had a problem. Say again, please. I'm not. Flight experiments. I think I better use the jack.
Idiots! So you and your tiny space drill figured out how thick the moon's crust is. Earthside crust, 31 miles thick. Space-side crust. How can we have a space-side crust and an Earth-side crust? This moon is rotating with 13 degrees per day. And something that is rotating also have a rotational pole. And it wobbles also. And why is this called the Eastern Sea? 14 days later it's the Western Sea. Because the moon is rotating. Jupiter C, Explorer 1, a modified A4 V2 rocket. Under the direction of Weener von Braun. And satellite instrumentation of Explorer 1 was designed and built by Dr. James Van Allen of the State University of Iowa. So those guys must have approved this footage, otherwise it never made it to the outside. So back in the days you'd educate people on this. Okay, then we must follow this. If all this equipment is built by Dr. Van Allen, and we had real researchers researching the data, then this must be real. Von Braun also built a V2 rocket, and also this Vanguard rocket, which is a direct descendant from the V2 rocket, but I don't see it. I already have a video about the V2 rocket. It's a joke. If I was you, I should check my video out and try to debunk it for yourself, like I did. Direct descendant, I don't see it. Diameter 1 meter 65. Diameter 1 meter 14. So this must have a different engine. Maybe it's the same type of engine. Yes, it is the same type of engine the V2 rocket had. This V2 rocket engine only burned for 60 seconds, and then it reached maximum speed, which is 5,700 kilometers an hour. And after the engine stopped, it could fly another 200 kilometers without propulsion. That's about the same we see here. This one even increases speed without propulsion with 9,000 miles an hour. So this one could go to space, reach an altitude of 140 miles, with a speed of 1680 miles an hour in a retrograde orbit.
By 1943, the V-2 was nearly operational, but occasionally one of the new birds would wander crazily out of control. One landed accidentally in neutral Sweden and the wreckage was forwarded to the Allies. Another landed in Poland alongside a stream where the huge pieces were discovered by Polish patriots. That night, the Polish underground
they have a camera present. Yeah, nice.
radioed the Allies, who immediately sent out a plane which brought the V-2 wreckage back to Allied Supreme Headquarters in London.
Behind enemy lines, you pick it up, okay?
Now, with both the Swedish and the Polish wrecked V-2s in their hands, the Allies quickly reassembled them. They now...
So is this the V-2 rocket? The V-2 rocket. Diameter 165. Wingspan 356. So if this is the rocket and this is 165, then this is a pretty tall guy. At least 9 feet. Compared to this 165 rocket, 5'5" in diameter. So is this a big guy or this V-2 rocket suddenly shrink? This is just trash. So Mr. Van Allen, did you all figure this out? By using your satellite, your tiny satellite. And those rockets, Explorer 1, Explorer 3, that confirmed the existence of the belt in early 1958. Explorer 1, Explorer 3, Explorer 4. Going to space with 1680 miles an hour, and you're teaching all this stuff to the kids of the University of Iowa? You should be locked up for life. Post-mortem, of course. They should dig up your grave and dump it in the ocean. Piece of shit. Just like the rest who approve this garbage. Yeah, all those people. Here, this smart Dr. Van Allen with his pipe, building all kinds of electronics for satellites.
Its development was under the direction of Dr. James Van Allen. He had already designed some of the complex electronics instruments that the Vanguard was supposed to have hurled into orbit.
Yeah, we know, we just seen that.
Having anticipated a possible Vanguard failure, he had designed his instruments so they could also fit into the tube-shaped satellite that the Jupiter C would carry into space. At their 150-acre research and development complex at Pasadena, California, Dr. William Pickering and his associates were racing toward the same deadline, 90 days to put a satellite in orbit. Their job, Phase 3, build and package the rocket's upper stages that would take over once the Jupiter C had lifted the satellite into space.
That's some very small electronics.
Assembled, the satellite appeared small.
Yeah, it looks very small.
But if all went well, 7.5 minutes from the time the giant missile bearing it would leave the Earth, the cylinder, now called Explorer 1, would be hurtling independently through space at a little over 18,000 miles an hour.
So 18,000 miles an hour when it reached the last stage, of course. And when it's in orbit, 7.5 minutes after launch. How high this satellite went? 220 miles or 354 kilometers. 354 kilometers was closest point to the Earth, and 2,515 kilometers was the farthest point. That's called perigee and apogee. So I guess it starts its orbit at this altitude. Putting Explorer 1 into an orbit with a perigee of 358 kilometers. So 254 kilometer altitude. And then it's in the orbit. 354 kilometer in 7.5 minutes, like this guy say.
But if all went well, 7.5 minutes from the time the giant missile bearing it would leave the Earth, the cylinder, now called Explorer 1, would be hurtling independently through space at a little over 18,000 miles an hour.
That's 2,832 kilometers an hour.
Independently through space at a little over 18,000 miles an hour, if all went well.
Yeah, if all went well. Imbeciles.
General Medeiros orders launch at 10:30 that night.
If the launch is at 10:30, then why your clock is set at 3:30? Idiots.
Check all operating lights and meters for proper operation. 1, fire command, fuel tank pressurized. Launch tank pressurized, missile power. Ignition, base stage. Lift off. Lift off.
The missile is in flight, but the success of its mission is still in doubt. It will take another hour and a half to know whether the satellite is in orbit, and this is the most tense and agonizing wait of all.
Why it take 1.5 hours? You have some high advanced equipment, so it takes 1.5 hours. That's more or less orbit time. So you can only find out its orbit when it made one orbit. I thought you had all those tracking stations over the Earth. With tracking stations you don't have to wait 1.5 hours. Imbeciles. You guys are just full of shit.
Hello, Len. You can send this off to the secretary. That our satellite is definitely on orbit.
In Washington, a new kind of American hero was born. Men like Pickering, Van Allen, and von Braun, with the scientific ability, foresight, and determination they had shown, were to lead America into the new age of space.
Now you lead us into bullshit with your tiny upper stage satellite. This is just modified fireworks, idiots.
This dedicated team had lifted our first satellite into orbit. In the contest for space, the race was by no means tied up. The Soviet Union, with its tremendous heavy satellites, was still ahead.
And you are also full of shit. All imbeciles. One by one. And I don't think those people work for free on this trash. This is paid by tax dollars. as you can see, one by one, big frauds. Pieces of shit.
President Paz, Dr. Braun, my scientific advisor, Dr. Weener, the gentlemen. I'm happy to accept the invitation to address the National Academy of Sciences. I would suggest that science is already moving to enlarge its influence in three general ways: in the interdisciplinary area, in the international area, and in the intercultural area.
How much have you seen this documentary? I assume your Harry Potters all approved it. Pieces of shit. Scientists, my ass.
In short, waste money, and I think a giant C-1 booster F-1 rocket engine, a giant of the Saturn rocket. In short, and I think that moon is there. Base budget, waste money, a staggering sum, waste money, more than 5 billion, 345, 400 million, 10,000 billion. We must pay money every year. Pay what needs to be paid every year. Base budget, waste money. I think that we must pay what needs to be paid. Waste money.
And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Waste money. Waste money.
I don't know who did that.
Waste money. Waste money.